This week with day 5, we're going to begin with a mixed review again of what we've covered in this chapter. So this chapter began with something called arc length. The arc length is really asking us to determine the length along this curve from A to B. And the way that we find the arc length is we take the fraction of the circle, which in this case is 157 degrees divided by 360 degrees, times 2 times pi times the radius, 13 inches. They've asked us here to round to the nearest hundredth. Rounding to the nearest hundredth means we're going to put everything in the calculator, including the pi. So we'll end up with an arc length of 35.62 inches. Area of the sector. For the area of the sector, they're really asking us for the area of this pi piece there that I've just put those green lines through. Now, to find that area of the sector, we also need the fraction of the circle, which we already said was 157 degrees divided by 360 degrees times pi, and now it's times the radius squared, because pi r squared is how you find the area of a circle. So for the area of that sector, we will get 231.54, and it will be inches squared. They asked us to round to the nearest hundredth, so we put everything, including the pi, into our calculator. And the label for area is always in whatever the units are, squared. The rest of the chapter, we talked about some segments in circles. And one of the first segments that we talked about were chord segments. For chord segments, the pattern that we tried to remember was first part times second part will equal first part times second part. So if we think of this chord segment first, the one highlighted in blue, we'll be taking 4 times x. And then thinking about the one that's highlighted in yellow here, we'll be taking 3 times 16. That's our setup. The rest is really just algebra. We have 4x equals 48, so x would work out to be 12. The next segment we're going to talk about and review were secant segments. Secant segments had a different pattern that we remembered. In a secant segment, you take the outside times the whole length of one will equal the outside times the whole length of the other. Now, in these problems, I did suggest to you that you first label and identify the whole length. So on this green one right here, that whole length would be x plus 5. On the blue one that I've highlighted down here, that whole length will be 6 plus 9 is 15. If we go with the green one first, the outside is 5, the whole length is x plus 5. And then going with the blue one, the outside is 6, and the whole length, as we said, is 15. Now it's just an algebra problem. We'll distribute 5x plus 25. 6 times 15 is 90. Subtract 25 and divide by 5. X equals 13. Another segment that we talked about, in fact, one that we talked about in this last day, day 4, was a diameter perpendicular to a chord. It will bisect the chord, and it will bisect the arc. So in this problem, we can see that we do have a diameter perpendicular to a chord. That means that these two pieces are going to be congruent. So we'll set the 7x plus 3 equal to the 5x plus 9. And again, it's just algebra. Subtracting 5x, subtracting 3, we end up ultimately with x equals 3. Okay, let's try another in this mixed review. Now, this one has a combination of two things. So this one does have one of our secant segments, but then the other one is a tangent segment. We've already reviewed the secant segments. The pattern for secant segments is outside times whole length. But for the tangent segments, we found out we only have an outside. So we just take outside times outside. Now with secant segments, once again, it's best to identify and label the whole length. So the whole length there would be x plus 12. So for that secant segment, the outside is x, the whole length is x plus 12. For the tangent segment, the outside is 8, so 8 times 8. Next, doing our algebra, we distribute x squared plus 12x. 8 times 8, of course, is 64. This was a quadratic equation. We must have 0 on one side. We subtract 64. X squared plus 12x minus 64 equals 0. We solve these in a variety of ways. Sometimes we factored, sometimes we use square roots, and sometimes we use the quadratic formula. This one, the most efficient manner would be factoring, so we will factor. It's a general trinomial. The first ones have to be x times x to give us x squared. To multiply to give us 64 and subtract to give us 12, I have to use 16 and 4. And to get a positive 12, I need a positive 16 and a negative 4. Now I set each of those equal to 0. On the first one, I get negative 16. On the second one, I get 4. Now, sometimes both answers worked. This is not the case here. When we check them, only x equals 4 works. And once again, I will remind you, you must box your answers in this chapter. If you don't, they will be counted wrong. This one does not work here. Okay, let's move on to the sixth one in our mixed review. Now, this sixth one in our mixed review is two tangents to the same circle. Well, those two tangents are congruent. So that means that this one is equal to this one. Our setup is simply x squared minus 13 then equals 23. Doing the algebra, I'll add the 13. X squared equals 36. This one we'll solve by using square roots. We'll take the square root of both sides. There are two algebraic answers. We would have x equals 6 and x equals negative 6. And both will check here. So both work. And that is why you must box your answers. Let's continue with this mixed review. Number 7. Number 7, we have a secant segment and a tangent segment. When we had secant segments, I recommended that we first get the whole length. Now the whole length on this one, when I add those together, I have 2x plus 4. So for my secant segment, I will have x times 2x plus 4. For my tangent segment, 10 times 10. The rest is algebra, distributing. 2x squared plus 4x equals 100. We must have it set equal to 0. 2x squared plus 4x minus 100 equals 0. Now this one would be hard to factor, but we could make the coefficients smaller by dividing by 2. So we'll divide by 2, and we end up with x squared plus 2x minus 50 equals 0. Still, this one does not factor. So we're going to use the quadratic formula. And you must know that. A is equal to 1, B is equal to 2, C is equal to negative 50. So in the quadratic formula, negative b plus or minus square root b squared minus 4 times a times c, all divided by 2 times the a. Now when we work out what's beneath that square root sign, we'll have x equals negative 2 plus or minus the square root of 204, all divided by 2. And as we've seen multiple times, there are two possibilities. One uses the negative sign in the middle, and the other uses the positive sign in the middle. Keep in mind when you put this into your calculators to put a parenthesis around the whole top, so the calculator will know that's all on the top. Now for the top one, when we use the minus sign, we get x equals negative 8.14. For the bottom one, we get x equals 6.14. They told us to round to the nearest hundredth, 2 decimals. The bottom one will work fine, but the top one does not work, so we can't use that one. Number 8. Number 8 is one of those diameters perpendicular to a chord. So once again, we know it will bisect the chord, and it will bisect the arc. We can see the perpendicular there. So that means this piece will equal this piece, and this arc will equal that arc. Well, this time they gave us A to B was 30. If A to B is 30, that will tell us that this piece right here is half of that. So that piece is 15. They told us P to C was 8. So this one right here is 8. And then they ask us to find the radius. Well, I'm going to draw in this radius right here, and I'm going to call that x. And we can find that radius using the Pythagorean theorem. So I would have x squared equals 8 squared plus 15 squared. X squared will equal 289. I have to take the square root of both sides. We get 2 algebraic answers. We get x equals 17 and x equals negative 17, but only this one will work here. And that's because the radius cannot be negative. Okay, let's look at another one in this mixed review. Number 9. Number 9 is our chord segments. The pattern here is first part times second part equals first part times second part. Let's take a look at this one first. So first part is x, second part is x plus 8. On the other one, first part is 5, second part is 4. Now comes the algebra. X squared plus 8x equals 20. Subtracting 20, x squared plus 8x minus 20 equals 0. This time we can factor. Factoring is usually quicker than the quadratic formula. I'll have to use 10 and 2. Positive with the 10, negative with the 2. Setting each equal to 0. I end up with x equals negative 10 and x equals positive 2. In this particular problem, only the 2 will work. So you must box that. Let's try another one. Just one more. This is an application problem, and we had one like this just yesterday in our previous lesson. We have a secant segment, and we have a tangent segment. For this secant segment, the whole length will be x plus 1800. Once again, we're looking for the distance x that we have to travel along that trail. So we'll take the outside part times the whole length for that secant segment, and we'll take the outside part times the outside part for the tangent segment. X is on the outside, and then x plus 1800 is what we found for the whole length. For the tangent segment, 2100 times 2100. And from here on out, just algebra. Distributing x squared plus 1800x, 2100 times 2100, 441, followed by 4 zeros. We have to get 0 on one side. And I wouldn't even bother trying to factor something with numbers this large. So we're going to use the quadratic formula. The A is 1, the B is 1800, and the C is negative 441 with 4 zeros. Putting that into our quadratic formula, we would have negative 1800 plus or minus the square root, and then I have 1800 squared minus 4 times 1 times negative 441 with those 4 zeros, all divided by the whole thing by 2 times the A. And I always like to work out what's beneath that radical sign first, that square root sign. Negative 1800 plus or minus the square root. This time beneath that square root sign, I have a 2088 followed by 4 zeros. And now we split it into the two parts. One, of course, is when we use the minus sign. And the other is when we use the plus sign. When you do put this into your calculator, please remember to enclose the whole top in a parenthesis. That way the calculator will know all of that's divided by 2. It asks us to round to the nearest foot, so the nearest whole number. The top one, I'm afraid, is not going to work. The bottom one, however, comes up with 1,385 feet. So that is how far we have to travel along that trail. Now again, that one was pretty complicated, but you will be expected to do problems like that on quizzes and definitely on the test. So I encourage you to look at it a couple times if you need to make sure you understand how to do it. Best of luck.